Okay, in this video I'm going to talk about standard notation into scientific notation. Okay, first let's talk about what is a standard notation or standard number. A standard number is really just a plain number. Okay, so these are standard notation examples right here. All right, standard numbers are like 1,000 or 12,443, 5. You could also have 0.00415. These are all standard numbers, and so they're just numbers. You know, they could be numbers with decimals or just regular numbers. All right, a scientific number, however, looks a little different. And we'll change color here so you can see a little bit. Okay, a scientific number has a couple of things it has to have. Scientific. All right, the first thing it has to have, these are little notes here that I usually. All right, has to have one number in front of the decimal. All right. It also has to be multiplied by 10 with an exponent. All right, the number in front of the decimal, okay, can only be between 1 through 9. So a standard number is just a plain number, any number is there. But a scientific number, you have to have at least one number in front of the decimal. And so we're going to use a little demo here, or basically we're going to create one so you can kind of see what I'm talking about. Scientific number, you have to have one number in front of the decimal. That number has to be between 1 and 9. Can't be 0 and it can't be 10 because 10 is 2 digits. All right, then you have your decimal, and then you can have any number of numbers below that. You can have none, you can have billion. All right, but then it has to be multiplied by 10 with an exponent on it. All right. So in this case, if I wanted to say 3012, times 10 to the third power, then that is a scientific number. All right. The exponent doesn't have to be positive. It can be negative. All right. And so we'll have an example of what happens when you convert a scientific number into a standard number. Now, in this video, all I did was tell you the difference between a standard notation and a scientific number. All right, now I'm going to take a standard number and I'm going to change it into a scientific number. So we're going to kind of like go to the next page. So we're going to take a standard and convert it into scientific. All right, so let's take 32,000. Let's just say 32,000. All right, first thing I always tell my students is always try to find the decimal. Whenever you see it, you can't see it, you know it's at the end. So you know the decimal is at the end. All right, so we know it's right there. Now remember, we want a scientific number. So that means I want one number in front of the decimal. One number, that's all I want. And so I've got to move my decimal where there's only one in front. So that's got to be the number 3. All right, and then the 2 will follow between the decimal. Now, how do we do this? All right, so what we're doing is we're going by place value. Each place value is a mark of 10. So that's 10, that's 10 more, that's 10 more, and that's 10 more. See, that's what we're doing, and we're just going to count how many 10's place values we're going to jump. So as you can see, we go 1, 2, 3, 4. So we're going to say times 10 and we're going to put to the fourth power. Now, there's a couple of things that I always talk to my students about because they always get positive and negatives mixed up. The first thing we do is I always look at this as money. If it looks like it's more than $1, then it's going to be positive. Then my exponent will be positive. All right? If it looks like it's less than $1, then my exponent will be negative. All right, so let me give you one. So you can see 32,000. It's like more than $1. But let's say that I have another one here. And if you notice, this looks like it's... So this one, does it look like it's more than $1 or less than $1? Well, if you kind of look at the first decimal place here, you can tell that that really is less than $1. Okay? And so because that, we know our exponent's negative. But still the process still works the same. We want one number in front of the decimal, and that number has to be between 1 and 9. All right, and so we're going this way, and the first number is a 4. So that 4 will go there. Then we're going to say 1, 6. Now, again, remember all these are counting by 10, so there's one. We don't count this one. So I want to make sure we erase this so you don't count that one. All right, and we do go this way. So we go 1, 2. Now remember, our decimal is really right here. So we really only went how many decimal places? We really only went 2. Because we're only going to the number so we can have that front. So if you think about my original number, there really is kind of a 0 there. We're just kind of like not showing it. So let's go over that one more time just so everybody kind of understands what I'm saying. So we really want to put the number where there's one real number and it's right there. So it's going to be like $4.16. As you can see in my example, it does look like $4.16. And then I start with the decimal and I count how many place values I'm moving over. And remember, these are by tens. All right, so that means I multiply it by 10. And because it looks like we went 2 place values, it's 2 place values. Now let's analyze this. If I really took $4.16 and I multiplied by 10 square, and 10 square really is 100, right, that would make my number larger than $4.16. It'd make it almost $416. And that's not what we have here. Remember, our value is less than $1. So we're going to make the exponent a negative. So whenever you see a standard number where there's no ones place value, otherwise it's a 0, it's going to be a negative exponent. Whenever you see that the exponent is greater than $1, I mean the standard number is like more than $1, then you know it's going to be a positive exponent. And this would be a positive exponent.